So here we have a hypothetical data, and this data is actually about depression, data collected from 40 respondents. And this data was collected with the Hamilton Depression Rating Scale, Likert scale diagnostic instrument for the assessment of depression. So here you can see the 4 times data. The first is the time 1 data, that is actually the data collected before the treatment, and here we have treatment, the 2 types of treatment. One is the CBT and other is the EMDR. So the time 1 means the data which is collected before the treatment, while the time 2 is the data which is collected after during the treatment. The time 3 is the data collected at the end of the treatment, while the time 4 is the data collected at the follow-up stage. So we have 4 times of data, and now we want to know whether any changes occur in the level of depression from the time 1 till the time 4. And for knowing this, the change that has occurred in the level of depression, we need to conduct the general linear repeated measure ANOVA. So click on the analyze and go to the general linear model. So like the repeated measure is one of the type of general linear model, and after clicking on the general linear model, click on the repeated measure. So here you can see these boxes. So first you look at what actually you are measuring. It means what is the factor that you want to measure, and the changes that the changes that have occurred in that factor. So actually we are measuring the depression. So I write here depression. And then how many times the data was collected? So we have collected the data 4 times. So I write 4 here and I entered this, and then I click on the define. So here you can see we have 3 boxes. The one is the dependent, other is the independent, then the covariates. So we don't have here covariates. Only we have the dependent and the independent variable. So the dependent variable, as I previously told, should be continuous variable. Here we have the depression level measured 4 times, and we have the treatment, that is CBT and the EMDR. So the treatment is the category variable, consists of 2 category of treatment. So I entered the treatment into the factor box, while the continuous variable on, that is the level of depression, 4 times I entered into this dependent variable, that is within subjects variable. Here we have a lot of options. You don't need to click on each and every option. The only options you need is to the plots, and you may need the post hoc analysis, and you need some other kinds of outputs that you can get from the clicking option. So like here I can generate the plots, that is estimated marginal means, which can tell me graphically that how much change has occurred from the time 1 till the time 4 in the level of depression. So I can generate a plot by entering data on the treatment, that is the CBT and EMDR, and the level of depression. So we have the post hoc analysis. You can enter this and you can choose any of these things. Like here I choose the Banforni. So coming to the options, so you just simply select all of these factors, enter it here, and then click on the compare means. So and again here choose the Banforni. that is the confidence interval adjustment. Here you just click on descriptive and you click on the homogeneity test, and if you need the parameter estimates, then you can click on it, and you don't need to click on each and everything, because it would lead to the creation of so many tables in the outputs, and that can confuse the students, especially those who are weak in statistics. So click on the, as I previously told, that we assume that the significance level should be equal to or lesser than 0.05 level, and you can increase this or you can decrease this, but this is by default given by the SPSS. Click on the continue and then click on the OK. As I told you that the SPSS generates so many tables, so you just need to learn how to pick up the required, the needed data, rather than just cut and copy and pasting each and everything, and that would create a mess, and your result would be would be messy. So here, look at the descriptive statistics. We have two types of treatments, that is the EMDR and CBT. And during the time 1 level, the level of depression was high, as it is clear from the mean score. However, during the fourth time, the level of depression was very low. That is, you can see here a very low level, clear from the 0.60 and 0.96. But here you can observe that the level of depression, as reduced by the treatment, the EMDR has better helped in decreasing the level of depression as compared to the CBT. That is clear from their mean values and the reduction in these mean value with the passage of time. You can look at the Marshall test of sparsity, which is insignificant, and it should be insignificant, which means that no violation in the sparsity have occurred, and there is actually an equal level of variance that has occurred in the that is the change in the level of depression with the passage of time. So for reporting the Ftest results, we require the F value, and we require the degree of freedom, and we require the sparsity assumed. So for choosing the F value, as I told you previously, that we look at the epsilon, and if it is greater than 0.705, then we should select the Wien correction, and if it is lesser than 0.75, then we need to choose the Greenhouse-Kaiser correction. So here, if it is greater than 0.75, so we need to choose the Hein correction, and here the Ftest value is 1836.211 and significant at 0.00 level. So this is how you can report the F test value, and this F test value actually shows that significant change has occurred in the level of depression from time 1 to time 4. And the change that has occurred from time 1 to time 4 can also be observed with the post-hoc analysis, and that is actually given at the end of the output, and this can be observed by looking at how much mean differences are between the time 1 and the time 2 and the time 1 and the time 3 and time 1 and time 4. So here you can see that the change that has occurred in the mean values from time 1 and time 4 is again significant and is again visible. You can do this even manually by just like subtracting the mean values of let's suppose time 1 from the time 4, and you can get this what has already been calculated by the SPSS here in this table in the pairwise comparison in the post hoc analysis. So like here, the difference between the mean values in time 1 and time 4 is 2.260. So this you can also do it manually, like you go to the calculator and you just simply minus or subtract the 3.04 from the 0.780, and you get this 2.26, and this is how here already been calculated by the SPSS, that is 2.26. You can also check this change or the difference between each time by conducting separate t-tests. Unfortunately, the SPSS is not providing a t-test in this general linear repeated measure analysis, and for this you just simply go to the paired sample t-test, and like you can enter here the time 1 and the time 4, and you just click on the OK, and here you get this same 2.26 round off here as 2.26 or 2.25, and again it's significant, and the t-test value. So this is how you can get even the t-test, and you can know the changes that have occurred and whether they are significant or not. And you can also look at the estimated marginal means, and you can see here that the both therapies have helped in reducing the level of depression with the passage of time from time 1 to time 4. And however, the patients in the EMDR groups have more significantly reduced the level of depression as compared to that in the EMDR group. And like you can edit this if you want, like you can make changes, like you want to change the color, or you want to add some uh, other things, so you can like edit this. And but however, you don't need to make these changes. Like if you don't need to change. However, if you require the changes, so like here you want to add the title, so okay, you can add the title. You want to add this something else, so you can this depend on like you want to add the data labels or similar thing, whatsoever you want to do, you can do it here by editing this the graph. And you can report the results of this repeated measure ANOVA in this way. Like this is one of the example of how I have reported the results of repeated measure ANOVA. That is actually the examination in the reduction in depression symptom with the passage of time. So you can see here The outcome is actually in the Hamilton Depression Rating Scale reading, and we have two groups, that is MDR and CBT. So during the baseline, it was actually 3.06, and this is same that what I have previously told, that we have this table 3.06 and the CBT have 3.01. So this is how you can report the results here. We can see that during the baseline, the level of depression was high as compared to the level of depression during the follow-up stage. And you can, like I previously told you, that you can make changes in the chart that is produced by the SPSS, and you can see here we have the, the data labels here, and you can see that in comparison to the EMDR, the and CB, in comparison to the CBT, sorry, the EMDR group has actually it has helped, it has greatly helped in reducing the level of depression. And as I previously told you, that for reporting the F values, you need degree of freedom, and you also need uh, the scarcity assumptions, and you need the F value and the P value also. This is how you can report the results regarding the F values, which means that the effect of psychotherapeutic interventions are visible actually, and it revealed that the Hamilton Depression Rating Scales differed significantly across the 4 times. This test of severity shows that no assumption of severity was violated, and this this shows that the changes that have occurred in the level of depression were actually they were equal. Here you can see the time 1 till time 4, the changes that have occurred in the level of depression. For this, we have calculated the Ttest separately.